So if we look at this problem, we're given that P32 is a radioactive isotope with a half-life of 14.3 days. We're told that we currently have 21.9 grams of P32. How much P32 is present 5 days ago? So I'm looking at time and amount, so I know I have to use the first order integrated rate law. Now, to use the first order integrated rate law, which is right here, I need to know what K is. So I'm not given K, but I am given the half-life, and of course we know this is the relationship between K and the half-life for a first order reaction. So when I plug in my half-life, I get the value of K is 4.846 times 10 to the minus 2 reciprocal days. Now here's the first order integrated rate law as we saw it way back when in chapter 14. Of course, we're not looking at concentration, but mass, but I'm just so used to using those brackets. So what we're solving for is not what we have at time t. That's usually what we solve for. What we're solving for is our initial amount. Our initial amount is what we had 5 days ago, and we know what we have now. So we're kind of working backwards. So I'm giving that I have 21.9 grams now. I know what my half-life is, and I'm trying to figure out what my original amount was 5 days ago. So when I take the natural log of 21.9, this is what I get. And when I multiply K by T, this is the value that I get. And so rearranging my equation to get my unknown value all by myself, I'm going to add 0.2423 to both sides. And by the way, my units of day cancels out here. And when you take the natural log of a unit, the unit goes away. So at this point, I am unitless. So then I end up with 3.329 is equal to the natural log of my original amount of my reactant. And so to figure out what that is, I'm going to take the inverse log, which is E. So I take E to the 3.329, and of course E of natural log gives me back my amount of A. And I calculate for this problem 27.9 grams. And that makes sense because it's more than what I began with. And of course you will get different amounts to begin with. Sorry about that. Get back up here. You'll get different amounts to be different amounts and times, but it's the same procedure to calculate how much you had whatever amount of time ago the question asks.